Hi, I'm Tim Nichols, Head of Engineering at GFT, and today I'm going to take you through our Build with Confluent solution for Amazon Fraud Detector. So the business challenge that we're trying to address here with this is that a financial institution wants to detect potentially fraudulent trading patterns. Now, what we mean by patterns is not traditionally transaction by transaction sort of monitoring, but more monitoring around trading in aggregate effectively. So we want to look at how the trades look in aggregate. This is typically an overnight batch-driven process in financial institutions. And here we want to demonstrate that with Confluent and Amazon Fraud Detector, we can create a near real-time pipeline which tracks trends during the day. Our results should be allocated to a relevant officer for the nominated jurisdiction of the trading counterparty, which will demonstrate that we can show and join different data sources together to generate the input to the fraud detection. So our input data looks like this. Obviously, we have our trade and various different measures against the trade, like volume, price, direction, what product it is, what currency it is, but also we have our officer data and what their responsible jurisdiction is, and our counterparty data, i.e., which tells us, what counterparty jurisdiction they actually reside in. So typically, these pieces of data would come from different data sources. Officers and counterparties might come from a CRM type system, and trades would come from different front office trading systems. Now, our solution looks like the following. So just working it from left to right here, we have our different data items coming in to topics. In this case, we'll be generating that with a simple Kafka hook. And then we have a Flink task, which is where the majority of the work is done, where we pull those three pieces of data together and produce a windowed output of that data. And we'll dive into that in a bit of detail in a second. Then we move across to the AWS side, where we look at triggering Lambda to receive those events via a Kafka trigger, which is linked to our Confluent Cloud instance. Once we get those events, we batch by batch enrich and save those to a CSV input bucket. And from then on, we use an S3 trigger to take those input batch files and produce an outcome from the fraud detector API, which we save down into a results file, into a different bucket location. And for the purposes of this demo, we're visualizing that data using a Glue crawler and Amazon Athena to help us query that output. So if we now look at the solution itself, we have our Confluent topics here. We have our counterparty, our officers, our trades, and our windowed output. And where the majority of the work is done, as I said, is in our Flink job. So we're looking at grouping the data together in a tumbling 10-minute window. And we'll join in our counterparty and our officer data and produce different almost features, if you like, of the data, where we look at how many products have been traded, what they are, how many trades, sum and mean of various different financial measures of the trade, how many different products they've traded, how many different currencies they've traded in, and then looking for sort of corner cases of how many zero value trades they might have done, how many low value trades they might have done, which would be potentially out of character for that particular counterparty. So moving across to our Amazon S3, this is our input directories. We see we've got nothing in there right now, just because we've got the demo queued up. And then we have our consume topic Lambda task. So this, as I said, works on a Lambda trigger, which connects out to our Confluent Cloud instance, and with a batch size of 200 and a window of 30, we'll trigger this Lambda. And this Lambda is principally responsible for decoding the message content using an Avro deserializer, and saving that down to a CSV file, with the various different columns of data. It will enrich it slightly with a few pieces of data that are required for the fraud detection solution, but that's essentially what this does. Now, once that data hits the output bucket, we will then trigger a function to pick that data up and then submit that data item by item to the fraud detection API, which is this piece here, and obtain a result effectively. And then further, we'll then save that data down into CSV, and then this will then become available to our glue crawler, which is sitting over this particular S3 folder, which we can then start to query as we go along. So what I'll do now is I'll set off our data generation tool. And what we should see is a whole bunch of data now hitting Confluent. We'll just have a quick look at the trades topic here, just to see we're actually having some data now flowing in. And here you'll see within our windowed output folder, in a few seconds or so, data should start to flow into here. And we can see data now starting to arrive. Now this will trigger our S3 trigger. Here. So once that data starts to come into there, this Lambda will be triggered, hit the batch prediction API. Sorry, not the batch prediction API, the prediction API itself. Batch prediction submits a job that runs sort of asynchronously, and we want to keep this sort of as real time as possible. And then now we can start to see some outputs actually hitting that bucket now. So if we just have a quick dip into an Athena query here, we should now start to see some data flowing in here. So we have some data coming out, and we've just knocked together a quick notebook here, which will show us some information flowing out now, and we can visualize that. And then we can see now our various different reporting officers, the outcomes that have come back from the prediction API. There are some errors, probably due to outbounds data. But as you say, we've had an answer for the vast majority of this. And you can see, certainly in this instance, you will see high risk. Now, the reason you see high risk from this more so than low risk, which you would expect, is that we are generating random data, and we have a prediction algorithm which looks for randomness, or looks for anti-patterns in the data, which if you're using a random data generator, that's inherently what you have. Obviously, we can see this start to change as more data flows in. Just update our little data frame. We can see some of the counts starting now to increase for each of these reporting officers. And again, we see more data more and more data flowing into the bucket. So this is just to recap, right? So we've got a consumer Lambda, which is looking at our Kafka topic here, which stores the results into a CSV with some minor enrichment, which then triggers our prediction Lambda, which takes that data line by line, submits it to the prediction API for fraud detector, and then drops that data into an output bucket. And that output bucket is covered by a crawler, which therefore means that we can start to query that using Athena. And here we just have a very simple notebook here running that same query. And that effectively now allows us to start to see our data flowing in there. So if we just summarize really quickly what we've seen here. So what we've done is we've created a near real-time fraud detection solution, which could replace a traditionally batch process. The Confluent Cloud Platform has uniquely allowed us to perform suitably windowed aggregate functions on our source data, which is the key input in this case. And we've seamlessly integrated AWS and Confluent to provide that real-time fraud detection using the fraud detection feature. So thank you for listening to this Build with Confluent demo, and I hope you enjoyed it. Thank you very much.